All right, guys, here we go. Sam and Oliver have a question, so we're going to jump in first with their question. Which one is it, Sam and Oliver?
A 17B.
17B.
Let's go. Let's go. Yes, sir. We won that. We won the competition.
All right, remember when you label your triangles, that the sides are across from the angles. So it really doesn't make any difference where I put the A and all that. But if I put A here, then this is side A. So yeah, 15, and then side B is 12. Perfect. And I want to know how many triangles are possible. What are the options for answers? How many triangles could be possible? 2, 1, or 0, right? So that's it. I just got to figure out which one it is. So I hope your beady little eyes see that, because that's a clue that we are going to do the law of sines. And honestly, it's all blending together. I can't remember who had to do this already today, if it was another class. But we're finding an angle. So if you just type this in right here on your calculator, it's going to be some decimal. You need the angle itself, so you're going to have to do what? Second sign. And I got an answer. Now remember, sometimes when you type that in, it comes up an error. And if that happens, then you know there are no triangles. But I actually got an answer, so I got 42.72. But remember, there are actually 2 angles that have that sign. One of them is in quadrant 1, 42, and one of them is in quadrant 2, which is 180 minus 42. So that would be 137.28. So here's the deal. Law of sines flat out gave me this answer. So that triangle is possible. If there is a second one, the new angle will be the supplement of the original, 180 minus. So 180 minus, that's 137. Is that possible? No. So how many triangles are possible? Just one. If this had come out to be, 107, then they both would be possible. But in this case, nope. Just one. All right, who else did what the All-Stars did and found a problem? Liam? 6. These are polar coordinates. They are r, theta. Those are polar coordinates. We are changing them into rectangular coordinates or Cartesian coordinates, x, y. Now, there are a couple different ways to do this, but I think the easiest way is just to remember that x is our cosine and y is our sine. And before you get all weird about that, haven't you already memorized that cosine is x over r? Yeah. So this is just a variation of that formula. So x is going to be 3 cosine 7 pi over 6, and y will be 3 sine 7 pi over 6. Now, if this is a calculator problem, which it is not, we would just type that in. But now I'm going to have to work this out exactly. So what's 7 pi over 6 in terms of degrees? Pi is 180. So it's 210. Yep, it's 210 degrees. So I'm going to draw 210 in my standard position framework. Here's 210 right here. This angle right here, my reference angle, is the key. Use your common sense. If this is 210, then this much must be 20. So 1 root 3, 2. And these are both negative. That's so easy to forget the negatives. If you are drawing a picture in any quadrant other than 1, make sure you include the negatives. So cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. So it looks like our rectangular coordinates are negative 3 root 3 over 2 and negative 3 halves. So polar coordinates are comma theta, rectangular coordinates, Cartesian coordinates, x comma y. All right, Lucy, you had your hand up?
Can you do 21?
21. A box holds 10 blue, 9 red. Given that you choose an odd number, what's the probability that you use blue? Trying to think if I'm going to do a tree diagram for this. Let's see. I'm going to either pick blue or red. And then I'm going to pick odd or even, I guess. Okay, so what's the probability I'll pick a red or a blue card? A blue card out of this box would be what? How many cards are in the box? No. 19. How many are blue? So 10/19 probability of getting a blue one, and then 9/19 of getting a red one. Correct? Now, it has to be even or odd. All right. So if it's blue, what's my probability? Let's see. They're 1 to 10. So that would be basically 1. I'll use 10. That would be 5/10 and 5/10 for even and odd for the blues. And then the reds, there's only 9 of them. So the odds, there are 5 odds, so 5 ninths and 4 ninths are even. Right? Now this says, given that you choose an odd number, so let's find the total probability of odd, all the odds. So that'll be 10/19 times 5/10, and this one will be 9/19 times 5/9. So I'll go ahead and figure that out. Change those into fractions. Oh, I guess I might have done that. That's 5/19. And this one is also 5/19. Is that right? So that will be 10/19. Now that is the probability of being odd, of getting an odd card. Do you agree with that? Now, the question says, what is, if, given that it's odd, what's the probability it's blue? So the probability of blue given odd. Oops, given odd. All right, so that's going to be blue and odd over the probability of odd. Now I already did the probability of odd. The total probability of odd is 10/19. What's the probability of blue and odd? That was 5/19. So it looks like my answer is 1/2. My answer is 1/2. All right, who else sees something that we need to look at? 19. No, we haven't done 19 yet. 19 says find the magnitude of 3b. And we know that b v is negative 3i plus 2j. So again, this is just kind of the fancy way. It's called linear combination of I and j. It's just a fancy way of saying negative 3, 2. That's our vector. So what's 3 times that vector? 3 times that vector would be negative 9, 6. And then we want the magnitude of that. And the magnitude of that is x squared plus y squared square rooted. So what is that? Square root of 117, which reduces so 3 root 13. Now I could have done that problem in a different order. What's the magnitude of this vector v? 9 plus 4, so root 13. If I want 3 of those, does it make sense that the magnitude would come out being 3 root 13? So that way the numbers are a little smaller if I do it that way, but it makes no difference which way you do that. Okay? Lucy? Which one? 33. Write parametric equations for the line through these 2 points. Well, this problem's a whole lot easier if you remember what parametric equations of a line look like. Parametric equations of a line, not this line, I'm making this up. Parametric equations of a line look like this. Anybody remember some observations we made about those equations? Tess?
Isn't it like their points? So, like the first one is the root 2 and the
Okay, now, this doesn't have to do with those points. This is just made up.
No, I know, but if you were to write one, if you were to
So what I think what you're saying is, I can never hear you, but I think what you're saying is that this right here represents a point on the line.
yeah.
And what about this part? What does this part represent? The slope. Now, the thing about the slope is, you gotta remember that slope is y over x. So this line, which is not the problem, this line, the slope would be 3/4. And a point on the line would be 5, negative 2. So the moral of that story is, if you know those 2 things, if you know your slope and you know a point, you can write your parametric equations. So if I do as Tess suggested and use this point right here, then this is going to be negative 2 and 1. Now, how am I going to find this part right here? Well, I'm going to have to find my slope. So what's my slope? 3 minus 1 over 7 minus negative 2. So 2 over 9. Now again, be careful. The 2 is the y. So you're going to have 2t and 9t. Now, could I have used my other point here? Absolutely. Could I have used for my slope, instead of 2/9, could I have used 4/18? Absolutely. Now, why would you do that? I don't know, but you could, right? Because the ratio there is what's important. So there they are. They're the parametric equations of the line. Very simple problem, but you do have to remember to keep it simple. You have to remember all that is. All right. What else?
What, can you say what the man is on top of that? Can you explain that?
Y is over y over x. X, y. That's the y, that's the x. It's sort. Dom? 9. Are these, what does orthogonal even mean? It means are they perpendicular to each other? Now, as long as they are two-dimensional, which these are, you could use the idea of slope. This vector was over 3 and down 7, so this slope is negative 7/3. This slope is 6/14, over 14 up 6. Well, what's the relationship between negative 7/3 and 3/7? Opposite reciprocals. So are they perpendicular? Absolutely. Now, if they're three-dimensional, which I think on your test when we did this, our vectors were three-dimensional, then this won't work. This will always work if it's two-dimensional. But if it's three-dimensional, then you want to rely on the dot product. So if we take, I'm going to call this B and this U. If we take these two and do the dot product, we have 3 times 14 plus negative 7 times 6. If they are orthogonal, that number will be 0. And it is, so we're all good. Okay? All right, who else?
Can you do 4?
4. So we have two numbers in polar form, and we are multiplying and dividing them. All these problems look so much harder than they are. Anybody remember our technique for multiplying them? The very first time we did it, I foiled it all out. That was a big mess. And then we observed we didn't have to
Times the
foil
first
it
two
out.
numbers.
Multiply the r's and add the
logs.
angles. That's exactly right. So this is going to be 24 CIS 250. So when we multiply complex numbers in polar form, we multiply their r's and we add their angles. What about when we divide them?
Sure.
I gotta make sure I'm dividing in the right order. Z1 over Z2. So I'm gonna divide these two numbers, so that's gonna be 2/3, 4 over 6. And then I'm gonna subtract my angles. And this is a little bit of a hitch, because in polar form, angles can't be negative. Theta must be between 0 and 360. So I'm going to have to find the coterminal angle for that. What's the smallest positive coterminal angle for negative 15? 310. How do we find coterminal angles? We add or subtract revolutions, right? 360. So that would be the quotient, that would be the product. All right, who else has one? Liam?
25.
25. If the cafeteria shows movies, there's a 92% chance they'll serve popcorn. If they don't show movies, there's a 41% chance they have popcorn. They show movies 2/5 of the time. Find the probability of, let's say, I'll make it up because I can't read it down there. So find the probability of popcorn. All right, so we're going to find the probability of popcorn. Okay, so we got movies, we have no movies, we have popcorn, we have no popcorn. Okay, if they show movies, got a 92% chance to an 8% chance of not. If we don't show movies, 41% and 59%. Show movies 2/5 of the time, so 2/5 and 3/5. All right, and I'm total popcorn. That's the question. Total popcorn. So I'm going to multiply movie and popcorn. So 2/5 times 0.92. No movie and popcorn, 3/5 times 0.41. And then since I could have either situation, I'll add them together. Okay? All right, what else? Liam, go ahead.
Hold on, I just realized we did 56.
Okay, I'm not gonna redo it probably.
Oh.
I'll get Neely, she had her hand up. Which one? 15. Find a unit vector in the same direction as -6, -8. What does it mean to be a unit vector? Magnitude is 1. Clearly, the magnitude of this vector is not 1. The magnitude of this vector is 36 plus 64, I think that's 10. So that vector is 10 units long. I want it to be 1 unit long. So I'm going to shrink it. So we're going to divide everything by 10. Now it's in the same direction, the proportion is the same, but the new vector, the unit vector, is -3/5, -3/5. That vector is 1 unit long. How do you make a vector a unit vector? Simply divide it by its magnitude. Yeah. Lucy?
You did 10.
Solve in radians, no calculator. So simple little trig equation, nothing complicated here. Cosine equals -1/2, just solving like regular. But now, I gotta figure out where that happens. Where does it happen that the cosine is negative? That's a negative number. Where is that going to be?
2 and 3.
2 and 3. So over here and over here. The cosine is adjacent over hypotenuse. So this would have to be √3. Remember, I'm doing this without a calculator, so it's special. How big is my reference angle right there?
5 or 6.
Pi over 3. It's 60, but I'm in radians, so it's pi over 3. And so is this one. But be careful, those are not the answers. The actual answers are in standard position. So it's the blue angle and the green angle. How big is the blue one?
2/3.
Pi minus pi over 3, which is exactly 2 pi over 3. And how big is the green one?
4 pi.
Pi plus pi over 3, which is 4 pi over 3. Yep. That's exactly right. Good. We have time for one more. Catherine, did you have your hand up?
Can you do 28?
Find the exact area of the triangle. Oh, yeah. Anybody remember how to do this? It's called a hero's formula. First thing we do is add up the sides, in other words, find the perimeter. So the perimeter of this thing is 33. So the semi-perimeter is 33 halves, it's gonna be 16.5. The And I'm doing this without a calculator, so I'm trying to keep it as easy as I can. So now I'm going to take that 33 halves, and I'm going to multiply it by what? Do you remember? No, not the sides. That minus the sides. So this is 20 halves, 24 halves, and 22 halves. So subtract 33 halves minus each of those, and that's what goes in there. And the reason I left it as a fraction is because I'm going to have to square root it, and my bottom's going to be 16, so that's going to make it much easier. All right, the purpose of review is to jog your memory, so hopefully you jogged.
Oh, is that what she told you? Yeah.
You know what you need to study.